You're basically describing what a product manager should be.
Not all product managers by far are technical enough to understand what the engineers are saying. And that actually leads to a lot of interesting conversations and people saying, oh, it's impossible to do that.
I agree, and I've been there many times. That's what I'm saying. It is basically exactly what a product manager should be. At least having the basic understanding of what is happening. And if people say, we have an issue, you should at least get the feeling of, okay, I get a rough idea of what is happening.
The complex bits are actually the model in terms of entities, so what you would call resources in OpenTelemetry, and how you organize the telemetry around them. And it takes a lot of work to actually be able to bridge effectively a set of semantic conventions designed in OpenTelemetry, also with the merging of Elastic Control Schema, on top of what you have been doing proprietary for years.
Welcome back, everyone. Welcome to this week's episode of SimpleBlock's Cloud Commute podcast. I know I say it every time, but this week I have another incredible guest. We actually know for quite a while. Again, there's some kind of a pattern. We've been colleagues before. We worked for the same company. Michele, welcome and happy to have you. Thank you for being here. So maybe just quickly introduce yourself, who you are, where you're from, what you've done in the past, and why do you think I invited you?
Well, it's a lot of questions. So my name is Michele Mancioppi. I am head of product at Dash0, an observability startup that is redefining what OpenTelemetry native observability means. My career path has been strange. I started out as a full stack engineer at SAP, then went into performance engineering with the JVM. Then turns out I had a bad moment having to figure out some very nasty bug, and the observability at SAP was not excellent. Spent a few years fixing that, and then I decided it was funnier to do observability than to use observability, transform myself into a product manager, joined Instana, where I met you, and I have been effectively like product person by day and engineer by night ever since.
All right, cool. How do you define engineer by night?
I code more than I should, and I let technical knowledge drive a lot of the decisions that I have. So I talk engineer with engineering, and business with product, and that kind of helps.
So you're basically describing what a product manager should be.
Not all product managers by far are technical enough to understand what the engineers are saying. And that actually leads to a lot of interesting conversations and people saying, oh, it's impossible to do that.
I agree, and I've been there many times. That's what I'm saying. It is basically exactly what a product manager should be. At least having the basic understanding of what is happening, and if people say we have an issue, you should at least get the feeling of, okay, I get a rough idea of what is happening.
I agree on that. I don't think the industry does. I see sometimes people like going directly from the university into product management, and I'm wondering, how is that going to work?
Yeah, it's exactly like the second group, which goes to university, studies IT because you're supposed to earn a lot. I'm sorry if I'm insulting anyone. That's just my personal experience, right? Blah blah blah. So they study informatics because it's so cool, and then they figure out software engineering in itself is actually really boring. Because they never had like the interesting problems to solve. I don't know. But yeah, then they either work as an engineer for a year or two, they have really hate it and go straight for management, whatever positions, product management, or as I said, right out of university, like, okay, let's fix that now.
Yeah, product management. I mean, I don't want to gatekeep, but I don't feel that product management should be a way to escape the sometimes unnecessary complexity of the technology. It's actually a way to increase your impact by effectively programming through Outlook.
Let's not go deeper into the Outlook stuff. Maybe Access. Anyway.
Don't carbon date. Let's not carbon date ourselves.
Yeah, exactly. So, tell us a little bit about Dash0. You said you guys are working on observability specifically towards like OpenTelemetry, which is slightly different from what we did at Instana, I guess.
Yes. So we live in interesting times in terms of observability. When we look back, for example, how the state of the art was around 2015 up to effectively 2020. If you wanted to create an observability solution, a very large amount of the effort had to be devoted in collecting the data that you would then process to provide insights. OpenTelemetry has appended that entirely, where there is a pretty professional, very high quality set of implementations, well thought through for collecting all types of telemetry. The quality of the metadata varies a bit, but the protocol, for example, OTLP, is pretty good. And that effectively means that the competition between tools is less about which data you can collect and more about what you do with that data, which is great because it's a part of observability that was completely underserved for a very long while. The user experience, both in terms of the way that you interact with the UI and the ease that you have to get your questions answered, I thought it was due to a refresh. And something else is that OpenTelemetry has a very rich set of correlations between the various signals being, traces, metrics, logs, zone profiles. They are intercorrelated in many different ways, and there is an incredible amount of value that you can provide to the user of the solution by actually tapping into those correlations in ways that, for example, even at Instana we didn't do.
Okay, interesting. Just to make sure that everyone's on the same page and understands what observability is, it's basically giving you insight into not just like a database or an application specifically, but basically also giving you insight all across the stack, like basically from the users clicking somewhere to the response that makes stuff happening in the browser again.
Yes, I mean, it depends on what you need in terms of observability. It depends on which systems you are taking care of. If your application is a monolith with a database behind, the kind of telemetry that you're going to collect is going to be different and probably simpler than the kind of telemetry you need to collect in some aggressively microservice distributed application, right? The trade-offs, for example, if you have more monoliths and less distributed systems, you veer much more in terms of metrics and logs than you do in terms of traces, right? If your application doesn't have a front end, you do not need to have real user monitoring. If your application doesn't have heavy load, you probably don't need profiling. So the kind of data that you need depends very much on what your application does. And it can go from something relatively tame, like logs and a few metrics, to a lot of different things that need to answer different aspects of your questions. And the more complicated the data is, the richer it is, the more important it is that the tool works with you to show you what's important to look at, and that it allows you to switch between these types of, between the signals very ergonomically, very quickly, so that you can actually start looking at the problem from different perspectives. I'll give you a very concrete example. Logs are usually very good in telling you that one particular thing happened, but it's relatively hard to find out what things a log is correlated with, which requests were being served as that the event described by that log occurred. The request is tracing, and tracing allows you to find out what happened before while serving the same end user request and what happened afterwards. So tracing effectively creates a path between all your applications that you can correlate events and different things. But also tracing is quite expensive if you want to store everything. So you start collecting also metrics, which is a very cheap representation but has less information. So you really need to be able to balance all these different aspects to get to a trade-off in terms of which information you have and how it is for you to query and how much it's going to cost you that you're going to be happy with.
And I think you mentioned something, well, you hinted at something very important, something we also always put in like front and center at Instana, and I see Dash0 is doing the same thing, which is you need context. You just don't need like a single signal or a single like lock whatever message, but you actually need the context in and where it happened, how it happened, in what order it happened, and that is basically, I guess, what you were hinting at.
I am known to say that telemetry without context is just data. If you see a metric called error with a value 0.8, is it good or is it bad? Should you wake up in the middle of the night? The answer is, who knows? What type of errors? On which system? What is the impact? Is it happening in QA? Can wait until tomorrow. Is it happening in production? It depends which service it affects. If it is the checkout service, probably there is all hands on deck. If it's happening in some back processing for the analytics for the product people, yeah, I can wait. They're not going to notice until tomorrow, right? So there is effectively it's better to some extent to have less telemetry, but very well annotated with context so that you understand what it means. And not only in terms of semantically what it means, like a metric called errors with value 0.8. Is the percentage? Is the counter? What does it mean, right?
Right, and is that like a standard value, or is there a sudden increase, a sudden drop, anything like that? Yes. It's always in the context or in relation to other values and previous and afterwards. So going with OpenTelemetry as being basically an official standard. I think it's not an ISO standard or anything, but there's like a big group that basically went for it and said, okay, let's standardize observability. Before that, there was it was open tracing, and the other one was Open Census, yes, but the name I always forgot about because nobody really seemed to care for that. And they basically came together initially and said, okay, let's standardize. And I think even at Instana, towards the end, when we were acquired by IBM, I think we already moved towards OpenTelemetry and also got engaged in the group, right? So how would you see that? I mean, now probably all open observability vendors go for OpenTelemetry. So it's probably not a competitive advantage, but how would you describe that? How would you say we do this, or why we do this?
Well, there is a bit to unpack here. OpenTelemetry is a very large project, and it is the second largest project in the Cloud Native Foundation in terms of contributions. And it effectively brings everybody that is in the industry for observability and a whole bunch of adopters. It is a admittedly complex solution because the kind of data structures that you need in observability are complex. Some aspects, some people say, are complicated. I think it serves a lot of use cases and it requires some mastery to make good of it. And that actually is both a product challenge and an opportunity, because in order to make good use of the very complex, very juicy amount of data and correlations that you have inside OpenTelemetry, you need to design a product around it. We see different ways for other companies to go about it. Some embrace it. Some give lip service to OpenTelemetry, and some rage on Twitter. I'm not going to name names, but
X, please.
No.
No.
So there is, for example, at Instana, I was the PM for all things tracing and agent, and I estimated in 18 months the amount of work it would take us to effectively map the features of OpenTelemetry on top of the similar data structures and concepts that we had from our own proprietary tracing technology, because it's not just about collecting spans and showing it in a trace view like Jaeger. Right? It's the complex bits are actually the model in terms of entities, so what you would call resources in OpenTelemetry, and how you organize the telemetry around them. And it takes a lot of work to actually be able to bridge effectively a set of semantic conventions designed in OpenTelemetry, also with the merging of the elastic common schema later on top of what you have been doing proprietary for years. It's very difficult.
So I think the other part, and that is, well, kind of related to the question before, at Instana, we basically, as you said, built the whole tracing thing. So we made, well, not agents, but collectors for all kinds of different technologies. And I think that is where an open source project of the size of OpenTelemetry comes in very handy, because basically everyone is part of it. Everyone implements collectors. Oftentimes vendors themselves, like database vendors, build them themselves and just contribute them or keeping them up to date themselves. I think that makes a lot of stuff much easier and probably even better, because a lot of the vendors might know much better what kind of data is actually necessary to run the database. How do you see that?
I would not use the word collector. The OpenTelemetry collector is something different. We could think of it as exporters in Prometheus. At Instana, we call them sensors. So effectively interfaces that would provide you telemetry. The fact that we see more and more instrumentation, more and more metrics endpoints built into libraries and frameworks upstream, in general, it's a very good trend. It's not always the case that these instrumentations do an exceedingly good job of following semantic conventions, because there is a large amount of lore that one needs to master in order to know which attributes to use in which situations. And sometimes there are categories of metadata that you may want to export that do not have a corresponding entry in the OpenTelemetry semantic conventions, and then you have the choice to engage the community or not. You'll go ahead with your own things. But it's definitely a very welcome trend. What I think has happened is that across the industry, so for example, at Instana, like the cost of actually collecting telemetry was immense. As the product manager for all things distributed tracing and agent, I had more than half of engineering working in teams for which I was PMing, and it was effectively trying to empty an ocean with a spoon to support all types of libraries in all types of versions, because often the work you need to do is bespoke, without being able to contribute to the library upstream. Right? There were some very bad offenders. Like at some point, I counted how many different HTTP server and client libraries we had to support in Java. It was upwards of 50. That's insanity. The fact that a lot of libraries are actually starting to integrate the OpenTelemetry API to define how, for example, the spans are going to look like, that's very, very welcome. In particular for technologies where the metadata is well understood, amazing. For things like metrics, we don't need to reinvent everything from scratch, because the Prometheus community has made an amazing job of creating all types of exporters. They were way lighter in terms of semantic conventions than OpenTelemetry is, but that's a gap that is being bridged by the two communities working together. Some steps. So recently, Prometheus released version 3.0. There are things that are going to happen over the lifetime of the 3.x range of versions of Prometheus that are going to make the life of the interoperation with OpenTelemetry much better. And I'm really looking forward to that. And then of the main signals that everybody uses, the logs are the ones that need less standardized structure. For example, when you look at the amount of semantic conventions for spans and metrics. They're like 10 times, 20 times more than what OpenTelemetry had so far to define for logs, because a lot of the things that you want to define in logs is more like where is the log coming from, and then a bunch of metadata about what this specific log means in your system. It means that that metadata is effectively specific to your application in large part. And there, the challenge with logs is less in terms of the quality of the metadata and more the fact that a lot of logging libraries or a lot of ways that you collect logs are not structured. For example, in containerized environments like Kubernetes, your application could directly emit logs towards an OpenTelemetry backend using the OTLP protocol, or you could let the container runtime collect system out and system error, put it on file, and then whatever is read in that file has to parse the log again to find out what the severity is, if it's a JSON log, which fields it as, or metadata, and there is a bajillion amount of different log formats. So, yeah.
Yeah, I think one thing you haven't mentioned was, sure, we had that many HTTP implementations in Instana, but with every single release, some of those broke, and you now had to build yet another implementation, which was just so slightly different. I remember that from Hazelcast as well, when we used to instrument Hibernate. It was such a beauty as well. We already crossed the 20-minute, but I have certainly 3 more questions. First of all, how would I get started with Dash0? You already said you went out of, or you went into beta. And as a mostly cloud Kubernetes podcast, I think people would love to understand how to get started on Kubernetes.
So we launched a beta a couple of weeks ago, and there is going to be something big happening around KubeCon. If you are in Salt Lake City, come by and say hi. For Kubernetes, there is a bunch of options available. We have, of course, a first-party operator, which makes the collection of all types of telemetry from your cluster very easy. Mm-hmm. For example, tracing Node.js applications out of the box, collecting the logs from the nodes, collecting metrics about the pods and kubeAPI, and there's going to be more. So trying to get a very healthy baseline of telemetry for your Kubernetes cluster with absolutely no toil on your end. Mm-hmm. If you're already using the upstream OpenTelemetry operator, great. Point to the Dash0, it works. If you're using OpenTelemetry SDKs in your applications, great. Point to the Dash0, it works. So there is a whole range of possibilities to get data into Dash0, because effectively the contract with the user is the OTLP protocol.
Okay, just to make sure, Dash0, like Instana, is a hosted platform. It's software as a service. All right. Then let's go to the last 2 questions. My favorite ones, actually. Like, what do you think is the next big thing? What do you see in the future? It could be observability cloud, databases, whatever, AI.
That's a very good question. I am pretty excited about AI technology and LLMs reaching the plateau of productivity. The amount of hype that we have seen on social media has undermined the actual value that these technologies can bring. I am looking forward for a certain category of individuals to move on to the next big thing. And so there can be very serious work done with those technologies. I love the some of the interactivity that LLMs bring. For example, I hate chatbots, but for example, using LLMs to explain complex data, that is very cool. There's also a whole bunch of maybe less fashionable but very powerful machine learning capabilities that one can use and integrate. For example, to parse structured logs, right? In terms of the general industry trend, and that's I'm not quite sure. I mean, we had crypto, now we have AI. I don't know what are going people to be to get excited about. I personally get excited by important stuff becoming boring, because then it means that you can really be productive with that and put it in the back pocket. Kubernetes is slowly getting boring. That is good. I don't know what's going to happen with cloud repatriation, or if the cloud providers are going to keep growing at a steady clip like we've seen. I don't know. I don't know how many people are going to go back to more monolithic architectures. My stance has always been that distributed systems are great if you have problems that distributed systems can solve, which tend to be more organizational problems than technical ones. So decoupling the output of different development teams. I would welcome applications in general becoming less complicated and easier to operate, because at the end of the day, providing a good quality of service to your users is what matters the most.
I think you mentioned two very important things. You want to see boring stuff basically taken away from you. And unfortunately I don't remember who said that, but a while ago there was this like meme going around like, I want AI to do my laundry so I can do the interesting stuff. And it's not like that I want to AI to do the interesting stuff so I can do my laundry. And I agree, LLMs, from my perspective, are unfortunately still very much misunderstood by a lot of people on how to use them. One amazing use case that we were talking about with a previous guest, and I'll link it, was he's working researching in cybersecurity, and they were working on cache warp, which was basically a bug in the CPU on Intel CPUs if you use multi-threading with cache clearance. And the interesting thing is that I don't remember the AMD documentation. No, I think it was a bug in AMD CPUs. The AMD documentation said the behavior is undefined. The Intel documentation for the same combination actually said it's a security hole. Don't do this. And he brought up the idea of like an LLM, you could actually feed both documentations in and say, okay, please find potential disalignment in the documentation and tell me about that. I think that is a really good use case, because nobody wants to read this. Like, I don't know what the X64 AMD 64 documentation is by now, but it's probably like multiple thousand pages. Nobody wants to read that.
I don't know how reliable can LLMs be in terms of summarizing data. There were recently studies about that, where the LLMs tend to miss important stuff and hallucinate others, and it seems to be something built in the way the technology
is
built in. I guess that there is going to be the need of a lot of error correction on the human side, and it is easier to correct false positives, so the LLM telling you that is broken, than false negatives, where the LLM does not tell you at all.
But I think the same is true for humanity, right? If you ask one person to compare those two things, the person will miss a lot, or just misremember or misunderstand. So you have the same problems.
I think that the incentives may be a bit, if somebody that goes and compares the two specifications to find security issues, I think they have some very specific drive and motivation that will help them.
Okay, that is very much fair. I give you that. Yeah. All right. Last questions. Is there anything else you want to tell the audience about?
Keep your software boring, and provide an excellent UX.
And sign up for Dash0 beta.
Try it out. I'm trying to make it as delightful and boring in terms of surprise that will give you as possible. But it should actually, hopefully, redefine what you expect from your monitoring tool. Go for it.
All right, cool. Michele, thank you very much for being here. For the audience, thank you for listening in again. You know the spiel. Same place, same time next week. And I hope you're coming back. Thank you, Michele.
Are you going to say to do the YouTube pleasantries?
Oh yeah, sure. Subscribe, like, subscribe, whatever. Just do the YouTube general YouTube thing.
Thank you, Chris. Bye, everyone.